Hi everyone, I'm Elsa Pastor, UIA expert working with the Guardian Project Consortium. This presentation is the first zoom-in activity of the project and is focused on providing particular insights on the water reclamation plan that is being implemented in Guardian. I will divide the talk into the following sections. First, I will provide a bit of context for those of you not familiar with the Guardian project. Next, I will talk about organic micropollutants and the environmental issues related to those. I'll talk also about the water quality of the Júcar River Basin, which is home to the Guardian project, and I'll present frontline technologies available to remove these pollutants. With all this background information, I will then give you the details of the Guardian approach used to remove OMPs from the wastewater that has been to be used for wildfire management purposes, and I'll finally end with some key messages regarding the overall subject. For those of you not familiar with Guardian, the project is a UIA initiative whose aim is to implement a strategy based on the use of recycled water for fire mitigation and protection, implementing preventive irrigation and extinction water spray systems, among other solutions with the integrated fire management approach. To this end, Guardian will implement the hydraulic infrastructure to supply recycled water from the wastewater treatment plant Turia 2 to several WUI areas of Riba-Roja and Paterna. The basis of this hydraulic infrastructure, the first block of the project in terms of implementation, deals actually with a water source, which will be found at the outlet of a water reclamation plant. The aim of the zoom-in is to provide you with a deep understanding of why we have to start our project dealing with micropollutants and how we are tackling this problem. Over the last decades, the presence of organic micropollutants, OMPs, in aquatic environments has become an environmental global concern. Micropollutants, also referred as emerging pollutants, include a broad range of substances: pharmaceuticals, personal care products, hormones, industrial chemicals, or pesticides. Concentration of these contaminants in aquatic environments are usually in the range of nanograms per liter to micrograms per liter. This is the reason why they are also named as trace organic contaminants. Those concentrations have so far hindered their detection and analysis, and so their removal. Since these substances have been designed to be biologically active, it has been observed that they can affect water bodies even at very low concentration, causing disruptive endocrine effects of aquatic species. The main source of organic micropollutants in aquatic environments are effluents of wastewater treatment plants. The existing conventional treatments in wastewater treatment plants have not been specifically designed to remove this type of contaminants. It is for this reason that many of them escape through the conventional treatment trains and end up in the main water bodies like seas or oceans, lakes, and river basins. The Júcar River Basin, which is home to the Guardian Project infrastructure site, is located in the central eastern part of the Iberian Peninsula and includes all drainage basins which flow into the Mediterranean Sea between the confluences of the rivers Segura and Senia. It is a large district. It covers an area of 43 square kilometers. The basin has an intensive network of automatic and real-time monitoring sensors in charge of informing on water quality and availability to the Júcar Basin District Authority. Recent reports issued by the authority warned on the poor water quality in terms of OMPs in the basin. In particular, surface water bodies of Júcar River Basin were reported to present unacceptable levels of plant protection products like organophosphate or organochloride insecticides. There are two sources of insecticides emissions in the Júcar Basin: a diffuse emission coming from the application of these products in agriculture, mostly from April to September, and direct single-point emissions through the effluents of wastewater treatment plants all over the year. As we have already said, many trace organic contaminants escape the conventional treatments of the existing wastewater treatment plants, as the huge majority of these plants have implemented conventional treatments based on physical chemical processes like coagulation, flocculation, sand filtration, or microfiltration that do not offer enough efficiency to remove OMPs. When water coming out from a wastewater treatment plant has to be reused, as in the case of the Guardian project, removing OMPs is even more important. To this end, advanced treatment technologies are needed. There are several state-of-the-art technologies available to remove micropollutants according to the water matrix to be treated, the efficiency required, and the operation conditions. Micropollutants removal through adsorption processes by activated carbons are one of those techniques. In these processes, the OMPs present in the liquid phase can be attached to a solid phase, that is, to the surface of the activated carbon, which might be present either in granular or dust form. Activated carbon has revealed to be effective. However, efficiency significantly decreases with heavily contaminated waters. Membrane separation processes can also do a good job, provided high-pressure systems are used, like, for instance, nanofiltration or reverse osmosis. These membranes are able to retain OMPs, but at a very high operation cost. In addition, when these techniques are used, contaminants are not destroyed, but separated into a concentrated stream, whose final disposal will be certainly challenging. And then we have ozonation. Ozone is well known to be a very good disinfectant. It is a strong oxidant that can react selectively with aromatic and aliphatic compounds. And interestingly enough, many pesticides have this type of chemical groups. So according to the description, adsorption onto activated carbon and ozonation seem to be interesting solutions for our problem at hand. In the Guardian project, reclaimed water will be used for the maintenance of La Vallesa wetland and for fire suppression uses, and therefore the removal of OMPs is especially relevant to avoid undesired effects in the receiving environment. One of the most important milestones of the Guardian project is the design and implementation of the water reclamation plant, which will be very soon installed in Candaturia 2 municipal wastewater treatment plant. Let's have a deeper look on this system. The Candaturia 2 is a conventional wastewater treatment plant which treats around 11,000 cubic meters per day of wastewater coming from 5 different towns, among which we find Riba-Roja and Paterna, home to the Guardian project together with Paterna municipality. The plant treats water through a chain of processes, starting with a pre-treatment phase in which big materials are screened, oils and fats separated, and suspended soils and floating organic materials sedimented. Following, a conventional activated sludge process, CAS, in the figure, is in charge of biodegrading the organic carbon and amino compounds. The clarified liquid coming out of the CAS treatment is the effluent that will be processed at the water reclamation plant, whereas the sedimented material is already treated in the sludge line. As we have already mentioned, the secondary effluent which is coming out of the CAS process has indeed presence of OMPs. Guardian partners, together with the Catalan Institute for Water Research, screened this effluent in July 2020, finding presence of pesticides, pharmaceutical compounds, and other substances included in the European Commission watch list, which is the list of substances that, according to the EC, have to be monitored in European waters. In particular, chlorpyrifos concentrations were found to be still above the admissible limits, although since January 2020, the use of this compound is no longer approved by the EC. In addition, the screening also detected several types of antihypertensives, neonicotinoid insecticides, antibiotics, and hormones. So in order to get rid of these substances, Guardian partners have designed an ad hoc water reclamation plan which will be integrated in a high cube container and installed in a corner of the facility, close to the secondary settlers and with access to a catch basin where the secondary effluent can be taken and also close to a drainage point where the reject streams can be sent and recirculated back to the primary treatment of the wastewater treatment plant. The water reclamation plan has been designed to provide a robust removal of organic micropollutants in order to guarantee the safe reuse of the reclaimed water for fire preventive uses and to minimize the impact in the receiving environment. The focus will be on chlorpyrifos, which has been identified as target contaminant. The trade consists on an ozonation of the wastewater treatment plant secondary effluent, followed by a biofiltration. The main objective of the ozonation is the oxidation of organic micropollutants and the transformation of the other substances not degraded in previous treatments into more bioavailable forms. Following, through biofiltration, ozonation products are adsorbed and degraded by microorganisms in a parallel filtering system, composed by a granular activated carbon filter and a sand anthracite filter. In this container, which is around 12 meters long, 2.3 meter wide, and 2.7 meters high, a complex setup of equipment is disposed to implement the water reclamation process. Within this small unit, we found pre-treatment filters, an ozone generation unit, a 5 cubic meter ozone contact tank, a nitrogen peroxide dosing system to increase disinfection efficiency, a biofilter with granular activated carbon, a sand anthracite filter, an accumulation tank of reclaimed water, a final chlorination unit, all together with pumps, pipelines, and control systems. A pretty amazing setup, only in 76 cubic meters. Where are we now in terms of implementation of this bit of the Guardian project? Well, during this last half of the year, the technical project has been elaborated and approved by EPSAR, which is the public authority dealing with wastewater treatments. And, as mentioned before, an intense screening has been performed to capture concentration values of OMPs in the effluent. In parallel, the water reclamation plan has been constructed, assembling all its components and testing its operation through pilot tests. Now, on-site civil engineering is taking place during these weeks. In particular, a concrete slab and pipeline connections are being constructed. So everything will be ready to have the water reclamation plant installed in Candeturia 2 by the end of the year. In 2021, the plant will start being run and optimal conditions will have to be defined to enhance efficiency, minimizing costs. To this end, different operation conditions will be tested with the aim of optimizing the water reclamation process in terms of removals, energy consumption, operation cost, and environmental impact. As such, ozone doses, addition of hydrogen peroxide, biofilters performance, or influence of other parameters such as pH, redox, or temperature will be assessed, together with the performance of sampling campaigns of organic micropollutants in the inlet and the outlet of the plant. Overall, a huge amount of work to be done ahead to ensure the optimum operation of the water reclamation plant after the Guardian project and the replicability of the solution in other type of scenarios. Just to summarize, let me give you some key messages from this presentation. Organic micropollutants in aquatic environments are an environmental global concern. Unfortunately, they are present in many different water bodies around the world, and they are found in the Júcar River Basin as well. Within the Guardian project, a new paradigm of using reclaimed water to fight fires is being implemented, among other actions related to integrated wildfire management. The use of reclaimed water will involve the maintenance of La Bellesa wetland and the feeding of fire suppression setups, and as such, it has to be OMPs free to guarantee undesired effects on the environment. To this end, an innovative solution in terms of a tertiary water treatment has been designed and will be implemented in the coming months with potential for its future applicability in other sites. The process, consisting of ozonation followed by biofiltration, is intended to remove not only chlorpyrifos, which has been targeted as a compound to be removed, but also provide a broad removal of organic micropollutants, including pesticides and pharmaceuticals, personal care products, and endocrine disrupting compounds. Water treatment, innovative technology applied to manage wildfires. This is just the basis of a smart use of water mitigation fire risk at the wild and urban interface. Thanks for watching, thanks for listening, and stay tuned for further information on the Guardian project implementation.